Welcome to Temple Builders Carpentry. Temple Builders, we problem solvers. Temple Builders, safety first. Okay, Temple Builders, today we talking about outside corners. We talking about inside corners. We also talking about the R value, okay, of different materials. First off, let's start with the ABCs of layout, okay? If you look right here on my board, we got X. X equals a stud. So anywhere you lay a X or you see a X in your layout, that means a stud, right? You got B equals a block. You got T that equals trimmer studs. And you got C, which equals cripple studs, okay? Now let's go over here to our through wall. Let's look at our example of our through wall over here. Okay, now you look at my layout. I don't know if you can get a close-up of this, but down here at the bottom, you got X right here. You got B right here in the middle, right? And you got X right here on the outside stud, okay? And as you see right here, you keep on X, X. Those are for studs. Right here in the middle for these posts, I got a B. That's for a block. So at this, what you'll call this a 3 stud and block, okay? Because it's gonna have 3 studs. You're gonna have 1 stud. There's 2 studs. And your third stud, if you come down here, this is your butt wall. When your butt wall comes into your through wall, okay, you add a stud right there. So that would be 3 studs. And in the middle, you have your blocks for spacing, okay? Now, you can possibly have, let's say, at the least 3 blocks in this post, all right? Now, this type of corner post, which is an outside post, that's on your through wall, okay? It's called a through wall because if you look right here in this example, it's running through your structure, okay? This other wall that comes right here is butting into my through wall. That's why this is called a butt wall. This is called a through wall, okay? Now your through wall has these 2 studs and your block over here, okay? So this type of corner post, outside corner post, which is basically called 3 studs and a block, it leaves a cavity. If you can see right here, see this cavity that's gonna be left in this block, okay? And then you come up, if you keep on going, you'll go to another block, would probably be a center block, and then past your center block, you have another end block, just like that, okay? So you got with those 2 large cavities, okay, on each end, okay, where you can't put insulation at, because you look right here, you see this on the outside, try to depict this sheathing that's gonna be on the outside, okay? You can look right here, you see that 3/4 sheathing that goes on the outside of your structure, okay? So when you're framing, you frame your home, then you sheathe it up, right? So the outside is gonna be closed up, all right? So when you put your butt wall, look at the butt wall, when you put your butt wall up against here, it closes up your cavity. So now you got air right there in that space, okay? Which an air gap has contributes to R value, but it's still weak, okay? So this would be called traditional framing, okay? And now you have more what they'll call advanced techniques, okay? Which would be this type of outside corner that's become more popular now that they're using, which is the Cali corner or California corner, okay? Now, if you look at this one, you see how it makes this L shape. If I'm looking down on it, okay, let's remove if I take my butt wall out, okay, because this is my butt wall right here. This is my through wall right here. If I remove my butt wall, okay, and I'm looking down on this right here, see it's L shape? It goes like that, boom, boom. Okay, let me see if I got yeah. So that's your L. See it? Boom, boom. It's an L shape that you made, that you're making with your 2x4s or 2x6s or whatever size studs you're using, okay? So that's how you know that's a Cali corner, because it has an L shape. Now what this does, okay, it's less building material than this one, than the traditional one, okay? That's one reason why it's become more popular, okay? It's less building material, and also it gives you backing just by setting this one flat, okay? setting this stud right here flat. Now you got backing right here, and you got backing right there for sheetrock. All right. Also, it allows you, if you stick your hose in here, or when you're spraying, spray foam insulation, you can get right back here with your insulation, spray foam insulation, and it has this corner, which you'll call it more energy efficient. All right, so that's why this is being favored more. Okay, now instead of using a block over here, traditionally you can, instead of using a block, go with the full stud. That way you won't have no voids in your post. Okay, because 2x4s have an R value. All right, now I still like this type of post. You see what I'm saying? And to me, if you got 3 studs right here at the corner, it seems to be more stronger in my head. That's what I'm saying. That's what I'm thinking. If you got three studs right here at the corner, which this would be called a 4-stud corner when you come in with your butt wall. Okay, so you have a 4-stud post. Okay, yeah, I would think it would be stronger than this Cali corner. Okay, but the Cali corner allows you to put insulation in there. Let's keep on going. Okay, now we look right here. When you pull your tape measure for your measurements, okay, you're gonna pull your tape measure, all right, at 15 1/4. Put a nail right there. Boom. Then get your hook for your tape measure and hook it right here where your nail at. Then stretch your tape measure out and then go 16 on center. All right. Now, when you laying it out, if you look right here, you're putting an X to the right side of your line. Okay. That's where your stud is gonna fall, on your X, to the right side of your line. Okay, you ain't gonna have to bother trying to center it on your line, trying to sit on a stud, get in the middle of the stud. No, put the X to the right, then that's where your stud gonna go. Okay, now this is important right here. Look down here at your butt wall. All right, now when you get ready to lay out for your butt wall, okay, you gotta pull from the outside, not from the wall. You can't lay out just from the bottom plate right here. You got to put in the material of your through wall. You see your through wall right here? And going back here, the thickness of your sheathing. Okay? So normally how they would do this is when they're building their walls, they'll build them on the deck. Okay, first off, what you would do, you would tack down your plates. Okay, tack them down with maybe some 8s. Okay, and then you lay out. You tack both of your plates down, and then you lay out like that. Okay, tack your plates down to the outside of your platform or your floor or your subfloor, and lay out. Okay. That way, if look right here, if I don't have these studs right here, and I got my right here bottom plate just tacked in here, okay, I can hook my hook right here on the outside. I'll be hooking it right here on the outside of this through wall plate. Okay, I can either add that 3/4 of an inch sheathing, or I can have a little scrap piece. I can nail a little scrap piece right here of the sheathing that I'm going to use, and then I can hook my tape measure on that and pull it out. Okay, but that's the point. If you can just read the drawing, okay, I hope I explained that correctly, but if you just read the drawing, you can see what I'm talking about, because your tape measure has to come all the way. It's not stopping at this butt wall, okay? It's going all the way over here, okay? So you go all the way over here, pull 15 1/4. Okay, put your nail right there, then get your tape measure up, then connect it to that nail, then pull it out. Then you're gonna go 16 on center. Okay, and look right here, the same thing's happening. Your X is to the right of your line right there, see? All right, now let's look at our inside corners right here. Also called a T. Okay, now your inside corners, when you build it, okay, you build them like it's a U shape. See, it's one stud, one stud. That's another stud. It's kind of like a U shape. And then your interior wall, this will be your interior wall or your partition, will butt up against it. Okay. So this is you can do this like this, a 2x4 that's facing flat. Okay. And you're gonna have two 2x4s on either side, on each side of the middle 2x4. Okay. That's what's gonna provide you for backing for your sheetrock. Okay. Your interior wall covering. Okay, all right, that's the U-shaped one. Another way you can do this, if you're using 2x4 studs as your framing members, you can get a 2x6. You just go with a 2x6, and it'll be wide enough for you can put your drywall or your wall covering. Okay, on that. All right, let's move on. Let's talk about R factors. Okay, because that's another reason why the R factor or R value. I said that wrong. Your R value, okay, which is a value of resistance, okay, is a reason why this Cali corner is beginning to be more favored more than a 4 stud corner, okay, because the homes these days they need to be more energy efficient. And they are more airtight, okay, than your traditional homes. Okay, so, but me personally, I still like the solid 4 stud corner. But let's talk about a value of resistance right quick. Okay, now, where do we start? Okay, let's say these are called factors. Okay, now these factors right here was totaled up to give you this value of resistance. Okay, now many different kinds of installation or insulation are available. Knowledge of how various materials used for insulation resist the passage of heat allow an architect or builder to select the materials best suited to insulating a particular building. Okay, so each type of material reacts a certain way or conducts heat. Okay, reacts to heat a certain way. Okay, now technical information about each type of insulation is expressed in letters that represent certain factors. Conductivity, K, is the letter that's is represented by is K. Okay, conductance, C, and transmittance is U. Okay, a value of resistance, R, is based on these factors. All right, now the British thermal unit, okay, BTU, is the unit of measurement of heat transfer. Okay, 1 BTU is the amount of heat needed to raise the temperature of 1 pound of water. So you can think about this as like let's say some type of pot on the stove that has 1 pound of water in it. All right, how much heat does it take to raise that 1 pound of water 1 degree Fahrenheit? Okay, and that's your BTU. Now you can go Google all this stuff, okay? And maybe me explaining it plus you Googling it give you a better understanding, okay? Heat is measured in British thermal units, BTU. 1 BTU is the amount of heat required to raise the temperature of 1 pound of water 1 degree Fahrenheit. Okay, heating equipment used in buildings such as furnaces and boilers is rated by its output in BTU. When specifying heat equipment, engineers must calculate the amount of space to be heated in addition to the expected heat loss in the building. All right. Now let's talk about this conductivity and our conductance. The best materials for insulation have a low K factor, okay? The best materials for insulation has a low K factor. See right, this highest K factor right here. Round down here is the lowest K factor. These are our examples of material. We have a concrete foundation wall. You see it has a high K factor. I got 4 arrows. This is the heat. This represents my heat. So the K factor stands for conductivity. It's conducting basically all the heat. Okay, so if you got an unfinished basement, concrete foundation wall, unfinished basement, that heat is going, okay, through that concrete easily. However, the wood stud wall, look right here, it's slowing down your heat. It's one left over. It's a arrow back here left over. So it slows down your transfer of heat more than concrete. Now look at the polyurethane foam insulation. Look, it's only one that's really over here. This is really retarding or slowing down the transfer of heat. This is how your K factor is set up, okay? Which is a factor that contributes to your R value, which is a value of resistance. Okay, let's keep on going. Okay, the best material for insulation have a low K or C factor. The K factor, conductivity, measures the amount of heat that travels through the homogeneous material. This is homogeneous material right here, okay, which means it's all the same, okay? This is all concrete, this is all wood, this is all polyurethane foam insulation, okay? Concrete, wood, and polyurethane foam insulation are examples of homogeneous materials. They have the same composition throughout. The K factor is a decimal measurement of how many BTUs per hour pass through 1 square foot of material that is 1 inch thick and has a temperature difference of 1 degree Fahrenheit between its inside and outside surfaces. Wood has a lower K factor than concrete, and polyurethane foam insulation has a lower K factor than wood. Okay, now the C factor, which is conductance, okay, is based on the same principle as the K factor. However, the C factor applies to materials of any thickness, okay, that are not homogeneous or that have air cavity, such as hollow concrete masonry units, okay? Now, transmittance, the U factor. The U factor transmittance is a decimal measurement of how many BTUs per hour pass through 1 square foot of the combination of materials that make up the floor, ceiling, wall, or roof area of a building when a 1 degree Fahrenheit difference in temperature exists between the inside and outside of the building, okay? Now, let's talk about the R factor. I ain't trying to hold y'all too long, but it's going, ain't it? All right, the R value, okay? This what really you're going to be seeing in stores and stuff, like when you go into Home Depot or, you know, Lowe's, any type of home improvement center to buy insulation that has an R value on it, right? So the R value, resistance, represents the ability of a material to resist heat flow. Most insulation products are labeled with an R value on the paper, on the wrapper, okay? The total heat flow resistance of a wall includes the R value of the material used to construct the wall, such as wood, brick, concrete, or hollow concrete masonry units, plus the R value of the insulation material placed in the wall. An airspace such as the kind found between a wood frame and brick veneer wall adds to the total R value of the wall. And that was kind of interesting to me right there. That air, I'm going to say this again, an airspace such as the kind found between a wood frame and brick veneer wall adds to the total R value of the wall. So airspace adds to the, airspace has some insulation, okay? Now, the total R value needed for a building depends on regional weather conditions. Since buildings in colder climates require more insulation, local building codes often specify insulation requirements for the area, okay? All right, so if y'all still here through all that reading, you know, congratulations. All right. that means that you really dedicated into knowing this stuff. So, and what I would do also is I would Google some of this stuff so I can know more about it, you know, because it's really important, the R factor, you know, the R value, I meant to say. These are our factors right here. Okay, so if you like this information, hit the like button, subscribe. If you want to contribute to Temple Builders, the Cash App is in the description box. The t-shirts will be coming out soon, probably a few weeks. All right, and we're going to continue quality material, producing quality material, quality content. Okay, also, this will go well with the shorts that I'm doing on the corner post. Okay, you put this information right here with the shorts that I'm doing on different inside and outside corner posts, and you should be able to put it together. Okay, all right, become my apprentice, Temple Builders.